there, everyone. Our topic for today is V equals to IR equation and IV graphs. What does that mean? That means voltage and current equation and voltage and current graphs. Okay, aim of today's lesson is for you to understand what is meant by Ohm's law. Objective of today's lesson is to know the relationship in Ohm's law, current, resistance, and voltage, and for you to interpret what IV graph means. And what does IV graph mean? That is current over voltage. Okay, so before we go to that, you need to understand what we meant by Ohm's law. What's Ohm's law? So Ohm's law states that the current flow through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance. What does that mean? I would love to explain this mathematically. Okay, the current flowing through a conductor between 2 points is, that means current between 2 points, that's I, is directly proportional. What do we mean by directly proportional, which is V, and inversely proportional to the resistance, that's R. Okay, so that's I equals to V over R. That is what Ohm's law states. Okay, but with that, we can cross multiply, and we have what? V times 1, that's V, and I times R, we have IR. Okay, so this is why we have Ohm's law to be V equals to I R. Now, what is V? V is the voltage across the 2 points. I is the current itself. Why? How is the resistance opposing this current. Okay, so voltage is the potential difference that causes current to flow in a circuit. That's the push of the current in a circuit. While current itself is the electric charge through a conductor in a circuit, while resistance is the opposition to the flow of this current in a circuit. So Ohm's law, again, Ohm's law states that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance. Okay, so now how do we derive this Ohm's law? I think I've explained that to you. I is directly proportional to V and inversely proportional to R. Then we have V equals to IR. So now what if we have, let's have some example here using this equation. If the voltage is 10 volts and the resistance is 5 ohms, calculate the current. Now, how do we calculate the current in this example one? I. Okay, we want to look for I when the voltage, remember that I equals to V over R, right? So if I equals to V over R and the voltage here is 10 volts, we have 10, and the resistance is 5 ohms, we have 5. So 10 divided by 5, then I equals to 2. So what's the unit of I, which is current? That's amps. Okay, fine. Now, example 2. So what if we are given the current, which is I, and we are given the resistance, which is 3 ohms? Remember, V is also known as IR, right? So V equals to, so example 2, we have 2 amps and 3 ohms multiplied by 3 ohms, then V equals to 6. Okay, so 6, and remember that voltage is measured in volts, that's 6 volts. So now let's go to how can we interpret a graph. Okay, how can we interpret graph? Fine. What is an IV graph? An IV graph shows the relationship between the current and the voltage for a particular electrical component. Now, the graph plots voltage on the x-axis. Remember what an x-axis is. So this is what we call, okay, let me just say this is a graph here. Remember, this is the y-axis and this is the x-axis. Okay, so the voltage on the x-axis and the current on the y-axis, then that is how IV graphs looks like. The current is on the y-axis. So this is current, we have I. That's why we call it IV graph. And this is V, which is the voltage. Now, here we have ohmic and non-ohmic conductors. Now, what does that mean? In an ohmic conductor like resistors, we have a linear relationship between current and voltage. What we call linear? Linear means a straight line. That means the graph will be on a straight line. I mean, the graph will be on a straight line, just as something like this. Actually, this is not a straight line, but I mean on a straight line. Okay. So, why non-ohmic conductor like diodes, light bulbs, lamp, these have a non-linear relationship. And what When something is linear, I said a straight line. So if we are talking about non-linear means at least it will have a little curve, something like this. So this is what we meant by non-linear. Okay. So I have a graph here for you to understand how it looks like. So in this figure below shows from an experiment where the potential difference, which is the voltage across a filament lamp, was varied. The current and voltage were measured. Now this is a non-linear graph. You can see this is not a straight line, a non-linear graph. And this graph, we have the current in milliamps and the voltage in V, which is volts itself. Okay, so now let's solve this question here. Use the value of the voltage and current in point P and Q on the graph above to complete the table. Now, at point P, what is the voltage? Now, this is P, okay? Remember, if you are looking for the voltage, that means the voltage is on the x-axis, and this is the x-axis here, okay? This is the x-axis. So, at point P, the voltage is what? 1. That's 1.0 volts. That's at point P. The voltage is 1. Now, what will be the current? Okay, what will be the current in point P? This is point P, while the current will be what? 20 milliamps. 20 milliamps. That will be the current. So at point Q, this is point Q. What will be the voltage at point Q? Now, taking this down. So at point Q, that means the voltage will be 3.5, ranging from 3.4 to 3.5 volts. That's point Q. While the current in point Q will be close to 45, which is 43 or 44. That's 43 or 44 milliamps. So this is how we interpret, or this is how we represent an IV graph. Okay, so that will be the end of today's class. Thank you for watching, and please don't forget to click on the subscribe button. Bye.